Hello guys, so welcome to another video. This is the latest edition of the custom paint animation series that I'm doing in my channel. So if you haven't checked out the other videos, please do. And in this video I'm going to create this animation that you're seeing here, a interactive particle effects animation. And everything you're seeing here is done on custom paint without using any external libraries in Flutter. So let's get started. So here we are going to create two new pages for this. One is for the widget along with the custom painter, and the another one is for our particle. So here I am creating a class called particle which holds the state of particle. So each particle in this animation will have a speed in x and y direction, a position which is also denoted by x and y, which is used for positioning it in the canvas, and also another parameter called radius which determine how big the circle is going to be. And with the help of the random class from the .math library, in the constructor we are going to randomly initialize the x and y positions, and also the x speed and y speed, and finally the radius of the particle. The only two things we need to pass into this particle class is the height and width of the canvas. Now the class that I'm going to create here will be a stateful widget, and here its name is the particle animations. For now it is only returning a scaffold, and when I run the app you can see we have an empty app here. And inside our app, the first thing we need to create is a list of particles. For this I'm going to create a member called particles, which will be a late initializable member. And inside the init state I'm going to initialize inside a for loop. And when I'm initializing the particles, I'm going to only pass in the width and height parameter here. After this, the next thing I have to create is an update method, which will be responsible for updating the UI. And here I'm going to use the timer from the data sync package. And for the duration, I'm going to pass in a duration of around 100 milliseconds right now. Now going inside the build method, I'm going to add a body, and inside the body I'm going to give the custom paint widget. And for the painter, we have not created anything here right now, so I'm going to create that now. I'm going to name it the particles painter, and inside the should repaint override callback I'm going to return true, because we do want to update the UI every time data changes. And now inside our constructor we need to get the list of particles from the widget. So I'm going to create a find member variable called particles, and I'll be initializing it inside the constructor. Now coming inside the paint method, the first thing I need to do is loop through all the particles inside the list. And inside our loop, first thing I will do is create a variable which will hold the current particle. And then I'm going to define a paint method which will be responsible for painting the particles in the canvas. And for drawing the canvas, I have to use the draw circle method of the canvas. And for finding the position, I'm going to use the offset. And I'll be using the x and y position of the particle class to find the offset. And for the radius, I'm going to use the radius we defined in the particle class. The next thing we have to do is call this painter inside our custom paint widget, and also pass in the particle data. We also need to pass in a container as a child, or pass in size infinity, it doesn't matter. And to make this look better, I'm going to pass in the background color black, so our white circles are now visible. And when I hold restart, you can see the circles are positioned randomly. But to see this assemble better in YouTube, I'm going to change the background color to white and the color of the circle to be blue. And when I hold reset, now you can see we have something on the canvas, and this will be the particles we will be animating later. Now in order to draw a line between the particles, the first thing I have to do is find the next particle inside the loop. Of course I'll be changing this later. If you want, you can skip to a later part. And I am going to define a lane paint object which we will be using to paint the lane. And to paint the lane we do need 2 points, and to get in these 2 options we need to use the current particles x and y position, and also the next particles x and y position. And on hot restart we can see then we have something going on the canvas. This is not what we are going to achieve. I'm just going through the steps that you need to understand. Right now there are lines connecting between all the particles, which is definitely not what we want. What we want to find is the distance between these particles, and depending upon the distance between them we only want to draw a line between the particles which are closer to each other. And for calculating the distance, we are going to use this Euclidean distance formula. Since we do have 2 points with their own s and y positions, we are going to use this formula to calculate the distance between each of the points. And inside our custom painter, we are going to create a new method called distance, which will be returning the calculated distance between the 2 points which we pass into this method. And here the square root and power method comes from the math library. So if you have not imported them, you will get an error. So basically we will be calling this method for every particle in our loop. And for that, the first thing we need to do is create another for loop. And the idea is that this loop will be called for every ith iteration. Because we want to calculate distance between each of these particles, we have to do this way. And here what we are going to do is, first of all, let's move all the code that was responsible for drawing the lines from outside the for loop to inside here. And after that, the first thing we have to do is calculate the distance between these particles. And for that, we are going to make use of the function that we have created already. And we're going to say that if the distance between any of these two particles is less than 85, then let's draw a line between those two. And from my experimentation before, this is the best number to use. And as we hot reload, you can see that for some particles there is a line between them, because those are the particles which follows our condition. The next thing we have to do is update our animation, and for that we have to make sure that the update function is called inside the init state. And also we have to make sure that we are updating the particles x and y position inside of CustomPaint. So inside our for loop, we have to update the position very first. So basically we will be incrementing the x and y position continuously as the animation runs. And when we hot reload, we can see that there is a movement here. But there is an issue. Some of the particles will be going outside the canvas constraints. So to avoid that, we are going to add some checks here. This check will make sure that if the particle's position is outside the constraints of our canvas, then it will be multiplying the x velocity by a negative value, basically, which means that the particle will now have to travel in the opposite direction. Similarly, we will be doing the same thing for the y direction as well. And when we hot reload, we can see that now the particles are constrained inside our canvas, and they are also bouncing back in between our canvas area. And this is the kind of behavior we are actually going for as well. So now our animation is looking more and more like the animation we wanted. So now to make this more better, we are going to change the appearance. Let's decrease the stroke width of the lanes. Let's make the lane thinner and also the color different as well. And now you can see that this animation is looking more and more better and closer to my goal as well. Now the next thing we want to do is to add some interactivity to this animation. So for that we are going to use the GestureDetector, and we are going to use the on pan update callback. Inside of on pan update callback, we are going to first of all obtain the current touch position, which is called the local position, and we are going to add more particle to the particle list. And for the width and height, we are going to keep it the same as we did before, but the only difference here is that we are going to change the x and y position. Here we are going to update the x and y with the current local position, so that basically this will be adding more particles to the area where we are dragging. Now when I hot restart, we can see that there is animation here, and when I drag and move my mouse, and because in this case I'm running it on Windows, you can see that more and more particles are getting added to the system. So now this is looking more and more fun and interactive as well. So this is basically the bulk of this video. I'm going to change the color. I'm going to add a background color and change the color. I'm going to play with the colors as well. But basically for you, this is the end of the video. If you like what you see and if you want to see more videos like this, mostly around creative coding with Flutter and CustomPaint, then please do subscribe to my channel. It will only encourage me to make more videos like this. And in the future, I'll be also making videos on other topics as well, covering the web development, backend development, and other development as well. So thank you for watching this video. Until next time, peace.